Have you ever stopped to think if you can actually have, too much of a good thing? Especially with something like safety in building.
Right. Like building something so safe it ends up being wasteful or maybe even causing other less obvious problems.
Exactly. It's a bit of a strange idea. But that's what we're diving into today.
Okay.
We're looking specifically at structural overdesign.
Hmm.
So using too much material, basically. And we're zooming in on residential villas in Oman.
Interesting focus. So what's the plan?
Well, our mission here is to unpack this specific research study. It looked into whether this overdesign actually happens, how much, and crucially why. We'll hear from engineers on the ground.
Ah, getting the different
Yeah.
perspectives.
And we'll look at proposed solutions too. The idea is to give you, our listeners, a real shortcut to understanding this whole complex issue.
Sounds good. And what's the main source we're drawing from?
Our primary source is a research article called Overdesign of Villa Structures in Oman. It was published back in December 2015 in the Journal of Engineering Research.
Okay, 2015. And it's significant. Why?
Well, it was apparently one of the very first studies of its kind to really focus just on Oman for this specific issue.
Gotcha. Setting a baseline in a way.
Exactly. And just to give you a bit of context, residential building is huge in Oman. It's the biggest part of their construction industry.
Makes sense. Lots of homes needed.
For sure. And the study looked mainly at Muscat, the capital. That's where about 40% of Oman's population lives, roughly 3.6 million people overall.
So a major population center.
Definitely. And get this, just between 2000 and 2010, they issued almost 29,000 building permits in Muscat alone.
Wow. That's a lot of construction.
It really is. So this issue of potential overdesign, it could affect a massive number of buildings.
Okay, so let's unpack that terms then. Structural overdesign. What are we actually talking about here?
In simple terms, the research defines it as building something stronger than the safety rules, the design codes, actually require.
Going above and beyond the minimum standards.
Right. But the study frames it as potentially being a waste of resources. Providing safety levels that maybe aren't really justified or needed.
Okay, so it's not necessarily better safety, just more material.
That seems to be the core question they're exploring. Is this extra material actually doing anything useful?
And is this just an Oman thing, or do we see this elsewhere? Particularly, say, in the region.
Good question. No, it's definitely not just Oman. The paper mentions similar things happening in other Gulf countries, the GCC states.
Ah, okay. Any examples?
Yeah, they mentioned earlier studies from Kuwait found things like an average of 30% extra steel reinforcement in floor slabs.
30% extra.
Yeah, and even more, like 60% extra in beams and columns. And some columns were apparently oversized by, wait for it, up to 240% in carrying capacity.
240%. That's huge.
Isn't it? And they also mentioned studies in Saudi Arabia highlighting problems like high maintenance costs, even some structural collapses,
What?
often linked to not having unified national building codes, and what the researchers called gross and wasteful simplifications in design. So yeah, it seems to be a wider regional pattern.
Okay, so there's a definite regional context here. How did the researchers in this Oman study actually investigate it? What was their method?
Right, so they got hold of the approved drawings, architectural and structural, for 31 villas. These were all approved by the Muscat municipality between 2000 and 2010.
Okay, a decent sample size over a decade.
Then they basically redesigned the structure of each villa themselves.
From scratch.
Well, they used the British Code of Practice, BS 8110, which is apparently used a lot in Oman.
Right, a common standard.
And here's the crucial part. They kept all the original design stuff, the building shape, the material strength.
Like the concrete grade, the soil-bearing capacity. all that
Exactly.
stuff.
Concrete strength was typically 25 to 35 millimeter at soil capacity, 150 to 250 kilometer aero manner, dimensions, loads, all constant. The only thing they recalculated and changed was the amount of steel reinforcement needed according to that British standard.
Ah, I see. So they're comparing the steel in the approved drawings to what the code strictly requires, keeping everything else equal.
Precisely. They use STAAD.Pro software to do the analysis and redesign, which is pretty standard engineering software.
Makes sense. Very methodical approach. So
Yeah.
what did they find? Let's get to the numbers.
Okay, the headline finding. Clear cases of extra reinforcement in almost all 31 villas.
Almost all of them.
Yep. And what's fascinating here is the scale of it. On average, the difference between the steel required by the code and the steel actually provided in the drawings was 48.5%.
Almost 50% extra on average.
On average, with a standard deviation of 24%, which tells you there's quite a bit of variation.
So some might have had just a little extra, others a lot.
Exactly. The range they found went from just 2.3% extra in one villa up to a massive 104.8% extra in another.
Doubling the required steel. Wow.
Yeah. And if you think about it in terms of weight,
Right, like kilograms per square meter.
yeah, the required amount, based on their calculations, ranged from about 26 to 71 kilos per square meter.
Okay.
But the amount actually provided in the plans ranged from about 41 up to nearly 88 kilos per square meter,
So consistently higher.
consistently. The average provided was about 61.6 kilometers high, compared to an average required of just 42.1 kilometer size.
So roughly 20 kilos of extra steel for every single square meter built on average. That really adds up.
It certainly does, especially across a whole villa.
Did they break it down by different parts of the building, like floors, beams, columns?
They did. And the biggest difference is the most extra steel
Yeah.
was found in the slabs, the floors and roofs.
Okay. How much extra there?
An average of 75.6% extra reinforcement in slabs.
75%.
Yeah. The range was pretty wild, too, from one villa actually being slightly under by about 3% up to one having 162% more than needed.
Goodness, that's a huge variation just in slabs.
Huge. Across all 31 villas, the total steel provided for slabs was 273 tons, when only about 160 tons were actually required by the code.
Wow. What about the other bits? Foundations, beams?
Footings, the foundations, were next. They had an average of 57.6% extra steel. Again, a big range, from 0% extra up to 182% in one case.
Still very significant. And beams?
Beams averaged 44.2% extra, ranged from 0% to about 103%.
Okay. So slabs, then footings, then beams. What about columns, the vertical supports?
Columns actually had the lowest average extra steel at 37.4%.
Still quite a bit over a third extra on average.
True. But the range here included some villas where columns were actually underdesigned, according to the code, by as much as 13%, although others were over by up to 78%.
Ah, under-designed columns. That sounds potentially worrying.
It does, doesn't it?
Yeah.
Especially given how critical columns are. So what does all this mean, all this extra steel?
Well, the obvious thing is cost, right? More steel costs more money.
Definitely. But the study points out other things, too, like it increases the dead load of the building.
Right, the permanent weight the structure has to support, just more heady stuff sitting there.
Yeah. And potentially, it could even affect how well the concrete and steel bond together if the bars are too crowded. Not enough space between them.
Huh. Didn't think of that. So it's not just waste. It could theoretically impact performance?
Potentially. This study does add a bit of nuance, though. It says some overdesign in columns might be okay, maybe even good for structural reasons, and the cost impact there is pretty small.
Okay. But finding under-design in columns?
That's flagged as a significant concern, absolutely.
So the big takeaway from the numbers seems to be inconsistency. And maybe a system focused purely on passing checks rather than optimizing.
That's exactly what the study suggests. Municipality approval ensures safety, maybe even over safety, but it seems to neglect the economy, the efficiency of the design. And that huge variability points to inconsistent design methods being used.
Right. Different engineers, different offices, maybe different interpretations or habits.
Precisely. Which leads perfectly into the next part. Why is this happening? The researchers didn't just run the numbers, they went out and asked people.
Ah, the field survey. Who did they talk to?
They surveyed 56 consulting engineers, the ones doing the designs, and 24 municipality engineers, the ones doing the approvals.
Okay. Both sides of the equation.
Yep. Wanted to get their perspectives on the reasons for overdesign and, importantly, potential solutions.
And did they find any immediate differences in how these groups work?
One interesting point was about tools. Most consultants said they used British or American codes and structural analysis software, like the State Brabo the researchers use.
Okay, standard practice.
But most of the municipality engineers reported not using structural analysis programs for their checks. They relied more on experience and professional training courses.
So potentially different ways of evaluating the same design. That's interesting.
It could definitely play a role. So when they asked the consulting engineers why the overdesign, what reasons came out on top?
Number one reason they cited, the lack of an authorized independent body specifically for reviewing structural designs.
So they felt the review process itself wasn't specialized enough.
Seems like it. Second was the lack of a mandatory engineering licensing system in Oman for structural engineers.
Right, professional standards and qualifications.
Third, they mentioned experienced engineers leaving design offices for better pay elsewhere. A brain drain, essentially.
Losing expertise.
Yeah.
That makes sense. What else?
A fear of structural failure. Maybe, the study hints, because they don't fully trust the quality of the construction work on site, so add more steel just in
A
case.
sort of safety buffer against poor workmanship.
Could be. Also, the influence of owners. Apparently, some owners believe more steel equals safer, and they pressure the designers.
The bigger is better mindset.
Yeah. And they also pointed fingers back at the municipality, saying reviewers sometimes ask for more steel than the code needs, or they're just hesitant to approve designs that reduce steel, even if it's justified.
Playing it safe from the reviewer's side.
And finally, consultants admitted sometimes just adding extra steel to get designs approved faster because the review process can take a long time. Easier to just give them what they expect.
Wow. Okay, that's a whole mix of systemic issues, experience gaps, fears, and practical pressures. Now, what did the municipality engineers say when asked the same question? Did they see it differently?
Their perspective was definitely different. Their top rack reason was, well, quite telling.
Yeah.
They said they often allow overdesign because they consider its cost impact to be very minor compared to the total cost of the villa.
So the extra steel cost just isn't seen as a big deal in the grand scheme of things.
Apparently not, from their viewpoint. They also admitted something interesting about their checks.
What's that?
They often compare the amount of steel in a design to the maximum and minimum amounts recommended in the codes, but without actually doing the detailed calculations themselves.
Sort of a quick check, a rule of thumb rather than a full verification.
Seems like it. They also felt minor overdesign could be a good thing, helping to overcome problems if the consultant doesn't supervise the construction site well enough.
Another layer of safety buffer, but this time against potential supervision lapses.
Exactly. And similar to the consultants worrying about workmanship, the municipality engineers felt poor contractor skills sometimes lead designers to overcompensate with more steel.
So everyone's kind of compensating for perceived weaknesses elsewhere in the chain.
It looks that way. They also mentioned designers grouping elements together to save time, like designing a whole set of beams based on the one that needs the most steel, even if others need less.
Simplification for efficiency, but leading to overdesign in some parts.
Right. And finally, echoing that earlier point, they confirmed they often check designs based on their experience with similar buildings, not strictly by following formal code procedures step by step.
So a lot relies on individual judgment and past practice, maybe more than strict adherence to the code calculations.
That seems to be a key theme emerging from their responses.
Okay, so we have these two groups, consultants and municipality engineers, pointing to quite different primary reasons for why this is happening. But what about solutions? Do they agree on how to fix it?
This is probably the most hopeful part of the study. Despite the different takes on the causes, they actually had very similar ideas about the most important solutions.
Really, they found common ground there.
Almost identical opinions, the study says, even if they ranked them slightly differently in importance.
Okay, so what were these top solutions that had broad agreement?
Three main things stood out. First, and this echoes the consultant's top concern, was forming some kind of special agency or body.
The independent review board idea.
Exactly. Made up of highly experienced, qualified engineers operating outside the municipality, specifically authorized to approve structural designs.
Centralized expert review. Makes sense. What else?
Second, making professional licensing mandatory for civil engineers who want to practice structural design.
Raising the bar for professional practice.
Right. And third, assigning a dedicated, specialized structural engineer to every large construction project.
Ensuring expert oversight on site, basically.
That seems to be the idea. So independent review, mandatory licensing, and dedicated project engineers. Those were the big three.
Were there any other solutions mentioned that seemed important?
Yes, a few others came up, things like establishing standard procedures for all stages of a project, from design to construction to handover.
More consistency across the board.
Yeah, and creating a shared database, like a learning system between the consulting offices and the municipality.
So everyone can learn from past projects and maybe common issues.
That seems logical. And finally, the need for a national standard for construction regulations in Oman to provide those clear, unified guidelines everyone can follow.
Okay, a comprehensive set of potential improvements there.
Definitely. Seems like there was a clear path forward identified even back in 2015.
So if we try and connect all these dots, this deep dive really paints a picture, doesn't it?
It really does.
We've seen this significant overdesign, nearly 50% extra reinforcement on average in these Omani villas.
Yeah, that headline number is quite something.
And it seems driven by a whole system of factors. No independent review body, No mandatory licensing, experienced people leaving, fear of failure, owner demands.
Reviewers prioritizing ease of approval or seeing the extra cost as minor.
Yeah.
Designers may be cutting corners by grouping elements, reliance on experience over calculation. It's complex.
It really shows that interplay between safety, cost, professional standards, and just the day-to-day practicalities of getting buildings designed and approved.
Absolutely. It's not just about the physics and the engineering calculations. It's about the whole ecosystem around construction, how people work, what pressures they face, what the incentives are.
And the study highlights that maybe the focus on safety has inadvertently created a system that's quite inefficient with resources.
Right. Is more always safer? Or is just right, according to precise engineering principles, actually the better goal, optimizing both safety and resources? This study really pushes that question.
Which leads us to a final thought for you, our listeners, to chew on. Given that both the designers, the consultants, and the reviewers, the municipality engineers in this study, seem to agree that the cost impact of this overdesign was minor, how does an industry change that perception?
Yeah, how do you shift the focus so that resource optimization and really precise, efficient engineering are valued just as highly as that perceived safety margin or the ease of getting that approval stamp?
What needs to happen to make efficiency a primary goal, not just an afterthought? What part of this deep dive into structural overdesign really stands out to you?